welcome everybody to, I think this is our last MIM Tech Talk for the semester. And I'm really pleased to have a former colleague of mine, Mialy Andrea Mananjara, to talk about enterprise knowledge graphs. Mialy has led many enterprise information management efforts during her 20-year career. And she's held hands-on and advisory roles in management consulting, financial services, and international organizations. We were just talking about this. I looked back, Mialy and I worked on a project on doing data quality metrics almost 15 years ago at a large financial services organization. And I'm really pleased to be able to introduce Mialy to talk about improving data owners' experience with the enterprise knowledge graph. So I'm going to hand it off to you, Mialy, and I'm looking forward to your talk. If you've got questions, please post them in the chat, and we will cycle back on them after the talk. Thanks.
Thank you, David, for the introduction. So my 20 plus years of experience in data management and data architecture. Like David said, I have a special interest in metadata. Most of my experience has been in the financial industry. When David asked me if I wanted to give a talk, my first topic was, hey, I'm going to talk about metadata, and I want to talk about enterprise knowledge graphs. It's been close to my mind for almost 10 years now. Started in 2012 when I worked for the Office of Financial Research, back then a startup office for the US Department of Treasury. And its main mission was to bring data to the financial regulators so that the next financial crisis would be avoided. So it has pretty lofty goals. And we were given the mandates to gather data from all of the financial regulators, meaning the SEC, OCC, FDIC, CFTC, CFPB, etc. And so it gave me a chance to actually start defining data architecture from scratch. And while doing that, I recognized that metadata held a very central place in how one should define data architecture. And I started looking into enterprise knowledge graphs. But for a small personalized trivia about myself, I come from Madagascar, where I was born and raised. Left after high school because I got scholarship to study engineering in France. So stayed in France for 5 years and then moved on to the US almost by accident while I got an internship at the United Nations in New York for what I thought would be a 5 months period. And I'm still here more than 20 years later. So to get started, why is it even a topic? Why are we talking about the enterprise knowledge graph, and who are these data owners that we're talking about? If we talk to executives, data executives inside of organizations today, a lot of questions are about, okay, I know there's big data, I have a lot of data, I spend a lot of money on data, but how come I cannot even find the data I need in my organization? While Google can pretty much index and search anything on the web. Why is it so difficult to get the data I need that I know exists in my own organization? And then to answer this question, there are those people who are called sometimes data owners, sometimes a different name. We go into more details as to exactly what they are, who they are, and what they do. And then we go into data representation and what does an enterprise knowledge graph bring to the table in terms of representing the data, the metadata, and how they actually help data owners. And then, yes, once you find the data, you need to do the analysis. How does enterprise knowledge graph help that analysis? And if enterprise knowledge graph is so great, how come it has not reached out to the mainstream IT people? What are the challenges to implementing an enterprise knowledge graph? and you go to a review of who today's market players are, and then the future. What does AI bring to the enterprise knowledge graph, and how can it help accelerate market adoption of the knowledge graph? And hopefully after all this, we go through a Q&A session in the end. I think, yes, at the end, not when I was presenting, or we never get to done. So what is this question we're trying to answer? So if you're in the data world, you have pretty much seen this picture, right? Like the data iceberg. The tippy top, you see all the nice pretty pictures and reports and visualization, data stories, data insights, the sexy stuff that people do, that they write into articles and they get white papers or academic papers on, right? But that's just not everything that happens before you can even start writing your reports, your visualization, your stories. You have all this humongous, very difficult and not very sexy stuff that happens underneath, which are, starting from the bottom, even finding the data. So starting to find the required data. If you don't have the required data, source the required data, deal with all the vendors and make sure that you get the data that you need. Check that the data is really what is needed for your fit, for your purpose, and it has the quality required. Try to understand and gather that data. So all that, and then eventually once you get to a production mode, get to talk to people that actually can do the automation and the transformation and the movement of the data. And again, check that the data sets that are automated are good, have good quality, and are fit for your purpose. So do all that before you can even do the things about the pretty pictures and the reports, and get that into to the user, in front of the users. That's the question we're trying to answer. How do we even find the data? How do we make sure that the data we're looking for is what's needed? And who is this data owner? That's the job of a data owner. And it keeps hiding, but anyway. So the data owner is that person in the middle, like a guy who bridges the chasm, the gap between the person who's gonna come and say, look, I really need to come up with this report today. I really need to provide this dashboard, and these are the issues I'm having. And then the data owner is going to be that person that's going to say, look, there's like, I don't know, 10 types of customers inside of the organization. Which customer is it that you want to find, right? So a person who knows in detail the ins and outs of the data, the life cycle of the data, which data is available when and to whom, and the person who might even be able to code a little without being a complete IT geek. But that person can also talk to data scientists and data engineer, so that that person can tell the data scientists, talk in terms of IT terms to the data scientists, and it talks in terms of business terms to the business me, subject matter expert or the data domain expert. So somebody really who can have left and right side of the brain, working, might have been an information systems major, an information management major. Sometimes I've even met people who are like theater major or music major who somehow became, started dabbling in the IT space and were a great fit to become a data owner. So that's the role. And this role as a data owner, depending on the organization and where you are, some people call it also data steward, or some people all call it also knowledge engineer. So really depends on the lingua and what people understand the words, the meaning of the role to be. My last organization, they called it a data owner, and that data owner person actually did a lot of a classification of the data, understood all of the business processes surrounding some very specific parts of the data, and the needs really of the end users. And the end users sometimes can be not just the business user, but can also be the people who are in charge of doing some data migration, for example, or doing some data transformation of the data. So migrating the data, for example, from an on-premise database to an Amazon cloud database. And so that data owner could be that person who understands, look, what's needed when you're migrating your application to the cloud. So it can be a very central role to the organization. And even though, depending on the maturity level of the organization, it can be somebody who is only doing this job as a part-time work, even though from my point of view, it's a very central, a very important role to have if the organization wants to truly become data-centric and make decisions based on data. So I'm crossing my fingers that it doesn't skip again slides, but yes. So, okay, so if the role of a data owner is to be able to find this the appropriate data for the business owners and the data engineers, where is that tool like Google that you need for enterprise data? So just to give you an idea, this I believe was in 2015, as of to the amount of data that's created alone. There's clearly a lot of data out there, and it's only getting bigger, meaning in terms of there's a lot more sources, Internet of Things, not just structured, unstructured, semi-structured data, a lot more formats. There's relational data, XML data, a lot more user types. So as we go and mature, users are a lot more technological savvy. So you have a whole spectrum of user types that the data owner has to somehow satisfy. So it makes it very difficult for the data owner to find the appropriate data for the users it needs. How does that person, that data go about to search? How does that person find the relevant results and find what you need and provide personalized results to make sure that what they're finding is actually what you need? Just like today, Google can present to you, relevant, trustworthy results that are ranked and personalize the results to you based on things that you have clicked on and that things that you have previously accessed. So that's the big challenge for enterprise data. First, the searchability, just to find the data that you need with the quality and the fit of purpose that you need. The response today coming from the marketplace has been to come up with what they call a data catalog. So what's a data catalog? It's really that, a catalog or repertory of data. At the very beginning, when I was looking at just in 2012 at what data catalog offerings were, a lot of them are very much oriented towards data engineers. So a lot of them were really about the lineage, the transformation rules, things that were pretty much not understandable by somebody like a business me. And wasn't really what we're looking for back then. We were looking for that data catalog that could merge both the business information and the technical information, and ability to not just make the data catalog a one-time effort to connect platforms and data sources and stop there. A lot of times, a lot of people start a data catalog effort and never update it because there just was not the bandwidth to do so. It was thought of as a secondary effort, things that I will do when I get around to it. So today's data catalog has gone a long way from that. So you now can connect and crawl automatically all the major data platforms and the data sources. You can schedule when you want to crawl. It will update everything for you in the data catalog. You can also create business glossaries where you can explain what the data means in terms of business terms for the users, understandable from the business users. There are some collaboration features. You can also incorporate ETL tools, extract transformation lineage tools that will make it sure that you know exactly the provenance of a data, where it came from, where it's going, who did what to it, and when, right? You can, so for the sake of governance, you can monitor, audit, and trace data, and you can tell, hey, look, if someone wants their data erased, like for GDPR, like in Europe, that they want to be forgotten, I can exactly trace where that information came from, and I can go and delete that person's information from those sources. I can query the metadata and try to optimize. I can put some context. I can control the security. I can also say, hey, look, if you're interested in data set A, maybe this is another data set that you might be interested in. So some way of suggesting which metadata you might be interested in. And this is a biggie, the last one, 10, provide somehow a unified view of data assets for business users. So those are the offerings that we today have for a data catalog. And you'll think, hey, look, there's been a lot of progress made. And yes, there has been a lot of progress made. If you look at the names here, you've got big players like Informatica, big players in extract transformation, Load tool in the data quality area as well. And they also have added a data catalog to their offerings. You have companies like Collibra and Alation, which have focused really primarily on the data catalog offerings, and Collibra and Alation are, in my view, the most important players in the data catalog marketplace today. And then you have Talent, also an ETL tool, and then people like Cambridge Semantics, which came really from the semantic web world, but have applied the semantic web more towards data cataloging and data prep, and some very specific use cases that they can serve. And then Alteryx, more of a data prepping tool really for data scientists. So yes, a lot of progress, but still a lot of very manual work that has to be done if you actually want to have an updated, trustworthy data catalog that has the information that you need. And a lot of it is because the metadata itself is still very fragmented. So even if you have the ETL or the data quality information that you can crawl, it's still very much IT focused, that you cannot push towards the end users, because the glossaries, the business information, the explicit representation of the knowledge has not been incorporated within the data catalog. Or if it has been, it takes way too much effort, too much manual work for it to be done. So at this point, I want to draw really a parallel with web search engines. I think at this point, we are where Yahoo was. I think this was a screenshot from the 1997, 1998 area, when Yahoo was creating directories and catalog pages manually. So somebody had to go and manually pull it in which pages belong to which category, which topic, which subtopic, etc. Which one was new, what could be read, and which one belonged where. So very manual, just like today's data catalog, or I would say maybe 20% crawlable and automatable, but a lot of the work still has to be a catalog person, an information management person, having to scroll and look through the information by hand to actually make sure that it's mapped correctly. And then, of course, 2000, sometime in 2000, Google came up with their algorithm where they were able to come up with a ranking, a trustworthiness, a linkability, and which links made sense for whom and when. which was a game changer and made all of the categories and the manual data catalogs, the manual web catalogs completely obsolete. So right now, I believe we are at this cusp. We're right almost there where we are going to say, look, we are not going to do things manually anymore the way that we are doing. The way that we have been doing this with Yahoo Web Searches, we're going to switch instead of the enterprise data to more of like a Google search type work. So yes, so just like, you know, for a Google Knowledge Card, which, like I said, was a game changer, and pulling in automatically information. If you Google Game of Thrones, for example, the series, you'll find, hey, look, who are the writers? You could click on the writers, you could click on the profiles, you could see who the cast are, and all this has been done pretty much in an automated fashion without anyone having to painfully go one by one to update the information. And part of why I want to go through this again quickly in the interest of time, but part of why today we are having to be so painfully understanding the metadata the way we are is because of how we are representing data. So 1960, we were starting with semantic nets, which was more of, okay, we have concepts, right? So we have concepts that we relate, then we have relationships between the concepts, and moved on to semantic nets. And then in the late 70s, beginning of 80s, we started thinking about, hey, look, we have relational databases and SQL queries that we can now look at how do we represent the data in terms of a relational data model. And that enabled us to create this table-like representation of the data, but they were focused a lot more on specific answers that we wanted to provide via a very specific application for specific groups of users, right? So very limited way of addressing and representing the data. Once we realized that, yes, the relational data models and the SQL are too application-centric, in the 1990s, we started thinking about, look, we need an enterprise data warehouse because we sometimes need to respond to questions from an enterprise data level point of view, right? So now that we had all these tiny little applications that we created, now we have to put everyone together. We have to say, everybody now we are belong to an enterprise data warehouse, and online, okay, I'm drawing a blank, but you need to have this enterprise data warehouse that everyone has to agree on the definitions of the data, on the data quality of the data, and the questions that we want to answer. Like, it can be very funny for people to realize that, yeah, look, even the definition of a customer in a lot of organization differs from divisions to divisions, from groups to groups. So when you get to an enterprise data warehouse, you have to say, everybody, we agree. This is how we understand customer. This is how we understand some calculated field. Like when I was working for a very large secondary mortgage financial company, there was a lot of work just dedicated to understanding what the mortgage amount was, right? Like, so what is the mortgage amount when you source the data? What it is when you fund that mortgage, and what does it become when you start servicing that mortgage, and when you actually sell or close the mortgage. So there's a lot of not misunderstandings, but there's a lot of work to be done across just getting to the same common understanding of what it is you're talking about. Then 2000 was really like, semantic web, Google, etc. Started really gaining traction. And then in the late 2010, 2012, 2013, the developers started saying, look, we don't really agree with the relational data model way of representing the data because it's very limiting to us. And that's what we started to say all about the NoSQL, not only SQL data representation that you see in the big Hadoop world. And now 2020, we start talking about knowledge graph. Actually, Google really marketed the knowledge graph 2012 when they started saying that, really that what they were doing was mapping pretty much all the information that there was on the web. 2020, we are now trying to merge together both the metadata and the data. And that's where we come up with this knowledge graph information. Also, the data fabric, where we interweave all different types of data sources that you have across the enterprise. So I tried to make that as quick as I could, but I don't know if I should go in more detail about what the relational data model is. Just quickly, if you go to inside of an application and you try to understand the data, and you'll see where the data owner's pain is coming from, is like people will show you, look, there's a data model, and this is what a typical relational data model will look like. And you'll have to go and look at all the data columns and all the tables and all the relationships. And, a lot of times there's no documentations, there's some very obscure namings, a lot of the documentation is not updated. You don't really know who you should talk to ask questions. You might not have access to master tables. Like I said, people don't even agree on what a customer is, right? And there's no master table for that customer. There's a lot of silos in the data, and the different lines of business have their own opinions. What sort of concepts are? You spend a lot of time trying to understand what's what for whom. And then really, if you look at that data model, that's just not the way that the business user is going to think of data. It's also not scalable. Each time you add a modification to that relational data model, you add a lot of repercussions across the existing data. It's very clearly not agile. I've given some weird, very egregious timeline when asking for changes to a data model and how to change the code, etc. More than weeks, sometimes months, so that just to incorporate changes to the data. And also here, the more relationships you get, the more complex your data model becomes, and then the more joins you are required to do, and then you have really poor performance, which is also where one of the cons of using a relational data model comes from, and why the NoSQL technologies had so much success. So yes, here's where we come, like, okay, if that's a relational data model, and why it's not so good anymore because of big data, all kinds of people accessing the data, types of users, etc. Is where the enterprise knowledge graph comes in. What's an enterprise knowledge graph? So you can look at this. This is the metadata. So you can see bubbles, right, that you call nodes as well. And you can see the relationships that you can see there as a directed arrows. So you can see like, okay, a book has an author, and then the book and the authors are the nodes, right? And even though it's a directed arrow, you can do queries in both directions. So you can see this. You can, it's also, I think, for a data user, for a business user, it's a lot more intuitive to understand than a relational data model. You can look, an author works with a publisher is located in a location, etc., etc. Then you may have recursive relationships for the location or for the books for the year. But where the strength of the enterprise knowledge graph really comes in is that on top of that metadata, or underneath that metadata, you can put in the actual data. So you can say Harper Green is the author, right? So you can have actual data. You can have all the relationships in, from the data that you understand inside of the knowledge graph as nodes and edges. We have properties inside of the nodes, and you have properties as well as in the relationships for the knowledge graph. What's in it for your data owner? Why you might think, oh yeah, so yeah, it's just a way of representing the data differently. But the data graph really makes it easier for the data to be looked at scale. You can connect graphs, data graphs. You don't have to go through that painful reconciliation of which data is which and have some primary key that everybody agrees upon. You can connect the data. You can break the silos so that just to be to say that the sum of all the data parts is really greater than the whole, to paraphrase a famous philosopher. And then, like I said, really the good thing is you can access the metadata and the data together. You don't have to care if it's structured on structures. You can combine structured, unstructured. The strength as well is that for artificial intelligence, it's easier to navigate the graph than it is to go and have to go index all the tables in a relational database. You can basically just point to an entry point in a graph database and navigate the graph, traverse the graph using that entry point. Right now, because the metadata is laid directly on top of the data, the knowledge itself is machine readable and very explicit. And because it's very explicit, it's somehow easier to share and easier to be understood by not just that application-centric view that you had in the relational data model, the relational database, but across all of the enterprise. And really, truly, which, like the holy grail of a data specialist, data professional like myself, you start treating data like a product with some measurements, not just like, something that somehow goes with applications, like traditionally it's been addressed as. So who is playing today? Well, who is in the marketplace, really? So if you look here, you see a lot of former, you have the big players. You have AWS, Google Cloud Platform is also starting to put in a play for enterprise knowledge graph. But you see some newer players like Neo4j, graph database players, Tiger Graph, Stardog or Anzo, which is a Cambridge Semantics company I was talking about earlier. If you see the circles, it's mainly also because some of the graph database players have focused on what's called LPG labeled property graphs, whereas the more traditional web semantics players are still in the RDF, the resource description framework world. But if you think about it, yes, and Stardog is as well a startup that's also trying to make a play in the enterprise knowledge graph marketplace. Okay, so is that where I am? Yeah, so what's coming next, really? Where I recall what's coming next. So really, there's going to be a lot more from my point of view. I can see a lot more collaboration happening in the enterprise knowledge graph, a lot of crowdsourcing, a lot of integration with some of the collaboration tools that already exist. A lot of intelligent cataloging, really, a lot of inferences for classification and governance. So not just relying on manual work to do classification and governance, to do lineage, to do mapping, a lot of artificial intelligence and a lot of inferencing and reasoning will be happening. More dynamic on the fly data queries and virtualization. And more machine learning models. So the model itself, all the data is going to learn from the context. So the more we know who's using the data, the more we know how the data is being used, how the data is being classified, the better our models will be, the better the information coming inside of the enterprise knowledge graph will be. Of course, I believe that the data catalog, if it wants to survive, can't just be that. a data catalog. It has to go beyond that. It has to go beyond just saying what data is available and actually serving the data, actually integrating with analytic tools so that once you find the data, you don't have to go somewhere else to actually do the analysis. You don't have to go somewhere else to do the visualization, because it will all be easier for you to do instead of an enterprise knowledge graph. And then really, and this, I've seen papers now written from leading universities on how you would actually do dynamic data representation and modeling, automated data modeling, because of the artificial intelligence laid upon the knowledge graph, that you can now look at the table or look at an incoming data source. And because of everything you have already done, instead of the enterprise knowledge graph, it will be able to dynamically, automatically represent and understand and model that data for you. So next, I don't think that's like in the next five years, but that's definitely where the some of this is going to go. Yeah, so if it's all that great, then how come, what are the hurdles? So why is it still not embraced by the mainstream IT? So I believe a lot of it is coming from standardization issues. There's not quarrels, but I mean, there's differences between how to depict the knowledge graph. So semantic graph versus labeled property graph. Semantic graph came really from the semantic web world, and the labeled property graph came more from people who wanted to use a knowledge database and be able to efficiently store data and efficiently traverse and navigate the data. So different goals and different ways of depicting the graph. So semantic graph is more, hey, look, there's a web. I want to be able to do some readable, to create some information exchange and allow machine readable information exchange on the web. Whereas, like I said, the label property graphs were very much more into efficient storing and efficient navigation of the graph. And then, of course, there's a lot of players still in the market, and there's a standardization issue. Once you have the graph and once you have the graph database, how do you query? A lot of them created their own query languages. Neo4j has Cypher. Amazon Neptune is using Gremlin. There is now, though, an effort, ISO standard process that everyone eventually will start to embrace the lingua franca of knowledge graph. That's going to be what I'm showing here, GQual. So once standardization comes in and once the understanding more of the differences between the different graph representation happens, and the power of AI is fully realized, there's going to be a lot more buy-in, and it's going to be get a lot more familiar to the IT coders and the data scientists to use a knowledge graph. So yeah, so I'm done. I'm waiting. I'm happy to take any questions you guys might have.
Thank you, Mialy. This is David. I actually have a question, which is earlier you made a reference to the difference is in the way that some of the different graph tools work, and you made a reference to labeled property graphs, and you contrasted that with RDF. I was wondering if you could share a little more information about the difference between those two models for representing a graph.
So the RDF would be a lot about using IDs or URIs, right? We'll not have more of internal properties themselves stored inside of the graph. So you'd have, let's say you have a URI that would be an ID for your property, and you would not be able to to store external data off of that URI. Well, as a labeled property graph, you'll be able to say, okay, this is the ID, this is the property type of the, for example, the relationship, and you could even attach, if you had multiple information, you could attach an array to that property. So you'd have, so you'd have that way of addressing the graph differently. You have in a URI the data, the type, hanging off of that that property, that edge. Well, does that make sense to you? Whereas the RDF, you probably just have like a textual property, like a URI, like HTTP, and then you'll point to some entity, some resource that you'd have to access to understand what it was.
Thanks. I'm going to remind everybody, if you've got some questions, you can either jump right in, or you can post to the chat and we will moderate that. In the interim, I've got another question. You, when you were talking before about the use of these types of things for data lineage and for catalogs, can you talk a little bit about what organizations, or at least the organizations that you've been dealing with, what are they using data catalogs for, and how is that getting folded in with some of this this enterprise knowledge graph?
So data catalogs, the way that I've seen them used has been, so I'll take an example. When I was at the US Securities and Exchange Commission, I used to work for the Office of Data Science and was working with a lot of economists and data scientists. And the questions they had was, the data is here. Where is the data? How do I get access? Who do I talk to? Who's the DBA? Like very, very basic questions. And then once I have access to that Oracle database, how do I actually write a query? Because some people don't write SQL. Some people are used to, let's say, SAS, right? So basic questions: where's the data? Who do I talk to? What can I do with the data? Also, okay, now I have access to the data. I learned SQL. I want to write a white paper, for example, on the data. Am I allowed to, right? Does the organization have the legal rights for me to take this data and aggregate it with another data set so that I can create and write a white paper that's available to the wide public? So questions like that, and you wouldn't believe how much work goes into just finding the data. You know, you start an email, you send an email, and that email gets forwarded 5 times, and then someone will say, hey, look, here's the data that you're looking for, right? And so that's where data catalogs are really coming from, because I think the more data you have, the harder it is actually for you to find the data. Because also, like I said, a lot of the data resides inside of specific applications, and the applications might have been created for a specific group, right? And to respond to the question you have, you might have to get access to data from more than one application. Let's say you have to access, okay, it's COVID time here. So let's say you want to create a dashboard for COVID, and you want to create you want to know how many people have had the vaccine. Do they get Medicaid? Do they get Medicare? Where do they live? Which provider provided them with the vaccine? Things like that. So you'll have to go and say, hey, who's the provider? That might be in one application. Do these people receive help with food? You know, that's another application. So to pull up all the information for a COVID dashboard, you somehow have to find some kind of crosswalk table, some kind of way to link everything together, and that can be very difficult to do. Even, you know, very mundane questions, it will take you a long time to respond to, because of the way that people think of data, which is, separate and in different applications. So that's especially for complicated, larger organization, that's the promise of the enterprise knowledge graph. And that's where, that's also where just having a manually drawn data catalog is not going to be enough.
Thanks. Victoria, do you want me to read your question or do you want to ask it yourself?
Thanks, David. I can ask it myself. This is coming, thank you so much. This has been such a wonderful talk. So the question I'm asking is coming from some of my time working at the Library of Congress. Some colleagues were starting to think about how do we use AI or machine learning in ethical ways to make discovery of collections better without perpetuating some of the gaps, some of the harms, some of the racist description, to give a specific example, or anti-Semitic description, embedded in some of our existing data. Do you have thoughts? Are there any affordances in the EKG that might help groups, companies, cultural heritage institutions spot AI, spot like harmful loops, or break down, some of that harm or mitigate it, or are these systems as prone to any other? And yeah, just curious to hear your thoughts.
Thank you, Victoria. I think that's a very important question that I think since we are learning from our own behavior using the tool itself, that unfortunately the tool itself probably will mirror our biases, right? Like, okay, we learn in the way that you use the tool, and then look, that's what the machine will learn to do. So yes, that's gonna have to be, like a specific effort that we'll have to, I don't know, if it's still something that we're learning to do, and if we see a woman and we think, I don't know, a cook, and we see a man and we say, I don't know, executive, and that's the way that we consistently use the tool, it's gonna have to be a separate way of addressing those biases, and we'll have to tackle that separately, because the tool will not know on its own that it's biased, right? So unfortunately, I don't really have any real answer to that question. I believe it's as we mature, as we start using the tool, and as we understand better ourselves and know where our biases come from, we will also reflect on how to make ourselves, stop ourselves, I suppose, from the biases. Might feel not a very techy issue, really. Probably more of a human issue, but the technology can certainly help with countering us from doing it. Or you can probably also have like ways of flagging, right? Like, okay, we are flagging if we see the bias appearing, and we can take steps to have some definite steps to counter the bias. But I haven't really seen it yet happen. It hasn't gotten to that level of maturity yet in the organizations I've worked in. So I haven't yet experienced this.
Great, thank you.
Thanks. That might actually be something that we should probably communicate back to some of these companies and to alert them to some of these challenges. I see that Simon has a question. Simon, do you want to ask your question?
Thanks, David. Hi, Mialy.
Hey.
Hi, everybody. Hey, I really appreciate this open knowledge sharing. I really appreciate University of Maryland doing this. And thank you so much, Mialy, for inviting me to attend this, because this is so relevant in my work right now. I'm an economist, as you know, but I just got put in charge of putting together metadata, where they call it a cookbook of the data that I prepare and maintain. But I didn't get that training when I was at Maryland. back in 1992s. I'm dating myself here, but we are using Socrata for publishing our story, for maintaining and storing the data. And then we do some calculation in the back end with some HTML or JavaScript language. So in order to do some kind of like a metadata, have you had any experience with how I can either create that outside or within an app like Socrata? Or like, what would you recommend that someone like me do to create metadata for something like that?
So if you start from scratch, a lot of times it's gonna have to be a mix of manual and maybe some automated effort. So maybe you already have all the data that you can extract out, but to really give it context, to give it the full-fledged understanding of what it means, you're gonna have to go in and type it yourself, like a librarian, right? Like, okay, I have all these books. Tell me how I can repertory the books. You have to go and, hey, look, maybe it has how do you call those codes? The QR, the barcodes in the back, and you can scan those, and you can maybe go to a WordCat and see that someone already did the work for you with the title and the author and etc. But if no one has done it, then unfortunately a lot of it has got to be very manual. And that's when I was saying you do it once. It's so painful manually that you probably will give up at one time, and they'll end up becoming very very outdated, unless like some kind of catastrophe happens and people rise and thinks, oh look, yeah, actually we need to maintain the metadata. So
Right.
unfortunately there's no real there's no silver bullet. A lot of times you scan the data, you crawl the data, you put it somewhere in a metadata repository, but you still have to somehow maintain it, and you still somehow have to make sure that the information that you have extracted out is relevant, especially for the people that you are serving. So I don't know, you are serving, I guess, economists.
Yeah, I work for US DOT, and we're in a very tiny statistical agency. It's called Bureau of Transportation Statistics. And we do everything. So I do economic analysis, I do, you name it, because we don't have the resource to hire a data specialist for everything we publish.
So yeah, go ahead, sorry.
No, I'm sorry. I really appreciate this, because this really is very relevant to what we are doing right now, and how we try to make our data available to people so that they can take over and control. It's all public data, like BEA, BLS, EIA, the standard public data, but because we use it.
Yeah.
Go ahead.
You have so if you're in the public space, you also have open data catalogs that you can use. CCAN, DCAN, I believe data.gov also has their own data catalog that you can reuse, where you can repertory the data sources that you used. Where it could be difficult is about when it comes to the lineage of a data that you're trying to point to. Because those tend to change a lot, right? Like, okay, even though the data source, okay, let's just think they're static. Maybe your coding, and I've experienced this a lot in my former work at the SEC. The coding itself tends to change a lot, right? And depending on who's the person writing the code, and who's in charge of now creating that report or that dashboard, they may change that code, from today, and 3 months from now someone else is joining, and there's not as much discipline, and you lose track of who did what and what was doing what, and then it's hard to understand the changes, etc. So that can become as well difficult. And then you can, you also have Git, code repositories that you can use and to go with your data repository. So, yeah.
Thank you. I really
Well, I'm
appreciate
happy
that.
to talk offline if you want. Yeah.
Definitely. Thank you
Mhm.
so much.
Thanks. I think we have time for one more question. So Victoria, go ahead.
Okay, unless anybody else wants to jump in, I'm
Mhm.
gonna go for it. Although I see something in the chat, David. Oh, that's you. Okay, so yeah, I guess my question is following on from that, and it's I work on crowdsourced data. These are produced using volunteer contributions, but they're run by libraries and archives or academics, and I think that there is a bit of a gap, and we're playing catch up in what do we do with these data sources. So yeah, we publish our papers, or we push policy changes, on clean water and air and things like that. But there isn't as much of a push towards a long-term deposit strategy to make the materials reusable and understandable. And I think that's kind of to Simon's point. So yeah, I wonder, do you have a sense of really who should be the stewards of these data, where there are so many people involved in its production, and it's, like, how do we make that glacier, the bottom part of the glacier, visible in the long term so somebody in 50 years can pick this stuff up and use it meaningfully?
So it has to come both from the top and the bottom, right? So it has to say, someone at the top has got to say, it's important that we can audit, that you can trace, that we can know that the white paper you wrote, the academic paper you wrote, this thing you wrote, that actually if somebody comes and challenges me, that I'm able to say where you got the data from, right? And what you did to the data. So there's that. It always helps, I think, when there's I think the federal government has a federal data strategy and a push now to have chief data officers. So once you have to have a bit of that high level influence to say that it is important, a signal from the top to say it's important, right? And once you have that, then you can also have, like my last effort at the SEC was very grassroots level. Was more about, hey, I wanted to help the scientists and the economists to find the data, and it really started from, okay, where's a spreadsheet and who has a spreadsheet and that contains the information about where the data is and who to talk to about the data. As to who really can own the data, it can be more of, okay, you can version the data. So there are efforts, actually. There are people who have dedicated efforts into data versioning, right? I don't remember it now, but it's like, okay, if I put this data in this data repository and I assign a version to it, and then I can point to it, and that version of that data will never change, right? And I will always be able to say at that point in time, when I publish this paper, this is a version of the data that I use, right? So there are definitely efforts that have recognized that issue, and that I've created group efforts and workshops around data libraries and data librarians and efforts for versioning the data. And I think from the technology side, because I believe there's been a little more time, to gain some discipline around versioning code. There's GitHub or GitLab. You have definitely out there code repositories that you can use, that you can also put in the versioning that you use, so that also when comes the time that someone has to take over the work that you have done, then not only can you point to the data that you created and the data that you massaged or transformed, so that you could come up with the spreadsheet or the results that you then cited in your paper, that person can also say, look, I'm taking over from Victoria. This is the data she used, and this is the code that she used, and it's residing in this, Git repository code. And then it's the SEC was a lot of A lot of educating, really. A lot of people learned coding on the fly, right? Like their main job is as a financial economist. They don't really want to code. They just ended up coding because of the nature of a job and because they had to. But if you go to them and say, look, you have to somehow version your data and you have to version your code, and they'll say, look, but it's only like a one-time effort. Why do you want me to go through all this painful exercise? But yeah, it is. I think it has to come both from the top and from the people working on the ground to say, yes, there has to be somebody owning the data. There has to be somebody owning the code, so that this is a disciplined, a professional way of producing data products. And we are data centric when we make data based off of decisions, and not just like on the fly reports or on the fly data visualization that you cannot justify how they came to.
Hey, I was also going to add that where I am, we have what they call the National Transportation Library, and they curate all the data that we publish or anything that we put out in the public. We are told to make sure that we talk to the librarian to make sure that those information that we work so hard on is curated properly. So that's a really good question right there.
Yeah, I think it's so the data doesn't need to be curated, right? What does that mean, though, that it is curated? At a different level, it means something, right? The data can mean different things to different people. The data librarian may think, yes, the data set name is this, the provider is this, this is the abstract, the description of the data, this is where the data format is gotten from. This is how often the data is refreshed or downloaded. But from there, you can have a lot more metadata that, depending on your constituency or the people who are using your data, can be very different. So yeah, it really depends on who you're trying to talk to. Yeah. Oh, thanks, Victoria. I will definitely check it out. Data fairness. So.
Thanks so much,
Yeah.
Mialy, and these were all great questions. Thank you very, very much for talking about this at our MIM Tech Talk, and hopefully we will be able to invite you back maybe next semester or next academic year to come talk about what you're working on then. Thank you, everybody, for coming today, and I think we're going to wrap it up. So thanks a lot.
Thank you for the opportunity, David. It was fun. All right.